Okay, this is part one of Robert Temple's A New Science of Heaven. Um, right from the get-go, this is for educational purposes only, and perhaps entertainment, but I don't think I'm that entertaining, to be honest, so, you know, I don't really care. So without further ado, let's get into this book because this is one of my favorite books, I believe. A New Science of Heaven by Robert Temple. How the science of plasma changes our understanding of physical and spiritual reality. And before you want to say anything, it doesn't really get too woo-woo. I didn't think he was. He sticks pretty much to the science that's, I don't know if you want to say cutting edge, because he goes through a lot of history of how we got to where we are now. But as far as mainstream science may concern itself with, but I don't think so. Don't get too caught up in where it says spiritual reality. Copyright 2022. Take a swig of this Gatorade. This book is lovingly dedicated to Lily Ashley, Elodie de Bosmole, Flora Wallace Sheldrake. What is related to Rupert Sheldrake, maybe? This lady, and Beatrix Williams, concerning whom the following definition may be thought appropriate: divine, from Latin divinus or divinus, maybe, of or pertaining to the heavenly. Special notes to the reader. At the request of the publisher, the author has removed all footnotes and endnotes from the book and placed them onto this book's dedicated website. I mean, when I first read that, I was really annoyed um, that 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 I got this copy of the book, at least the PDF of it, and to go to this website to get the freaking notes and everything. I didn't really do it because I just wanted to read the book. Maybe I can check on them at some point, but the notes contains a great deal of additional supplementary material and information of potential interest to readers, and are not just bare references. They are therefore recommended by the author to readers wishing for further information. The website also contains a large number of illustrations and photographs that could not fit into the book. I mean, we got some photographs already. Two of them, we'll just take a sneak peek here. We'll just have a little sneak peek. That's I forget what pages those are on, but we'll get to that eventually. But I guess I will have to go to this website eventually to have to look at more photographs and stuff. You know, see, including photos of many of the heroic scientists who battled against the herd thinking and blind prejudice over the past century and a half to found and develop plasma physics as a discipline, and those who are still struggling to extend its boundaries. Contents, here's the chapters. I think I might be able to get to finish chapter 2 in this first video. These first two chapters aren't very long. It's like one's 10 pages and one's like 15 pages. So we'll just see how it goes. Ebook. This isn't really an ebook. This is a PDF. Acknowledgements. You can always, somewhat glean information from like who the author acknowledges. Sometimes it can be pretty interesting. I wish to acknowledge the remarkable and unswerving support of my editor, Mark Booth, who believed in this book from the beginning. Having recently retired from publishing, Mark is now lost to all the other authors who might have benefited from him as I have. I can only regret that the armies of worthy authors to come will not be able to have his firm but friendly guidance towards the end, that ultimate end, making the book work. We authors can only repay him with our words, and these are mine. I must thank I must thank, as always, my wife Olivia for her continual and devoted involvement in this book, reading it, making suggestions, expressing doubts when necessary, and giving encouragement when doubts would be misplaced. I have never written a book without her help, and never more so, and never more so than with this one. I wish to thank also my very dear friend of many years, Chandra Wickramasinghe. Apologize for the mispronunciation. He is mentioned, I think, at least a good bit in this book, at least for a portion of it, for his vision and encouragement in exploring this exciting area of science, and for co-authoring the astrophysical paper reproduced in the appendix. So they've collaborated with each other, for at least that science paper, and you know and other things, I'm sure. Quote, but if there be a fifth nature, such as is introduced by Aristotle, this is the essence of the god of gods and souls. End quote. Marcus Tullius Cicero, Tusculan Disputations, Book 1, anonymous translation of 1715. Chapter 1, The Discovery of Clouds. I forgot I didn't put the background as clouds because of chapter 1. I totally forgot. That's the name of this chapter. But anyways, in October 2019, a momentous event took place, but as sometimes happens in these cases, no one noticed at the time. This event could have consequences from a humankind's view of its place in the universe for what remains of human civilization. It could entirely change the quote job description end quote of planet Earth. It means that the Earth Moon system is significantly different than we thought it was. It may well change everything. So why did nobody draw the obvious conclusions? People did eventually notice the discovery, for the findings came to be widely reported as a news item, as may have as may be seen from the googling the subject. And there appears to have been an unchallenged acceptance of the existence of what was reported. But still, there is a lack of any grasp of what it means. No one seems particularly concerned about it. It has been one of those news items that is exciting for a day and then forgotten. As new stories appear and, quote, the news caravan moves on, end quote, the implications of this anomaly remain unnoticed, and the strange facts potential to lead to great things is apparently unsuspected. History often works in this way. Who could have known that a failed and penniless artist in Vienna could end up starting the Second World War? We'll just not. We'll just let that. Uh, we'll just let that go. Let that slide. Who could have predicted that a spoiled 6-year-old rich boy who had continual temper tantrums and pounded the floor screaming insanely that his parents must obey him would end up would end up calling himself Lenin? I feel like, is that worded correctly? Would end up calling himself Lenin. Yeah, that's fine. In creating the Soviet Union. Who could have predicted that a New York property developer who likes gold doors and had no political background would become the American president? We're just gonna let all that slide. I don't need to comment on that. This is just, I mean, to get people's attention, grab people's attention, I suppose. He is a writer after all. But what happened in October 2019 was not political. It was far more important than that. What happened was that some astronomers saw something. I happen to have a roving eye for anomalies. I am always on the lookout for things that don't fit the present scientific understanding. And so in October 2019, I noticed that something anomalous had been observed by 3 Hungarian observational astronomers who actually looked through optical telescopes, as so many astronomers today rarely do. Well, that's sad trombone. I'm gonna have to put sad trombone on my soundboard. Anyways, in fact, what they observed had first been seen by a Polish astronomer named Kazimierz Kordylewski. I think that's how you pronounce it. Kordylewski in 1961. Kordylewski claimed to have seen a strange cloud at a particular location in the sky, the night sky, and he worked out that there must be two of them. Another at a corresponding location in relation to the Earth and Moon. See Figure 1. We'll get to it, I think, somewhere down here. So these soon became known as the Kordylewski clouds, quote unquote. However, no one else could see them, and that, everyone presumed, was that. 58 years went by, and then the Hungarian astronomers, to their great joy, observed the same cloud that Kordylewski had seen. Because it was extremely fine and emits no light, it is extremely difficult to see. But they studied it as closely as they could. It was at the same location that Kordylewski had indicated. This is a cloud between the Earth and the Moon, though not in a direct line of sight. It is very high above the atmosphere of the Earth and several times larger than our planet. Both of them are. I was fortunate to spot the paper that the Hungarians published summarizing their research. I contacted the lead astronomer of the Hungarian team through the website researchgate.net, on which I am listed as she is, and asked whether they had considered any of the plasma aspects of the cloud. The answer was that they were studying the cloud, quote, only for celestial mechanics point of view, not from plasma perspective, end quote. Plasma is what this book is about. But to put it very simply, plasma is matter that is made of incomplete or partial atoms, quote unquote, known as ions, and the much smaller particles known as protons and electrons. Plasma has sometimes been called the fourth state of matter, after solid, liquid, and gas, but finer even than gas. We call the physical matter that is familiar to us atomic matter, quote unquote, because it is made of whole atoms, whereas plasma can also be described as non-atomic or subatomic matter. Plasma is very familiar to us even though we may not realize it, for the sun is entirely composed of plasma, and the stars are plasma too. Plasma also manifests itself in lightning, including ball lightning and other mysterious phenomena we'll examine later. But plasma is otherwise, and for the most part, invisible. And we will be going into that unseen aspect of plasma a great deal as we go along. As someone who keeps an eye on what is happening in plasma research, I realized that I must have published something quickly to alert people to the true significance of this cloud, since the Hungarians were not dealing with the plasma aspect. I phoned my friend, Professor John Wickramasinghe, and Rick Ramasinghe, Wickramasinghe, who, as a retired professor of astrophysics, is an expert on all such things, and told him about the cloud and asked if he would co-author an article for a scientific journal discussing the Korolev clouds' importance from the plasma's perspective. We then wrote an article together, which was published in the journal Advances in Astrophysics in November of 2019. On a side note, all these highlights are mine this time. Um, Back when I was using Adobe for PDFs, I was highlighting, but the current PDF reader that I have now, that I can't seem to get it to work. I don't know what's wrong with it, but whatever. It is the article is reprinted at the end of this book as an appendix, which you already said earlier. The fact that the Earth-Moon system contains two giant clouds that together are 9 times the size of Earth means that we might be more accurate in describing it as the two-cloud system, and the Earth and Moon are thrown in it. These two clouds are made of plasma. Here's figure 1. Lagrange point 1, Lagrange point 2 is Earth, Lagrange point 3 there's Moon. I think those are Lagrange points. Yeah, Lagrange points. Figure 1, this diagram shows the locations of the Lagrange points, quote unquote, known as L4, and L5 of the Earth-Moon system, indicating the positions of the two clouds. In this diagram, the Earth is at the center and the Moon is directly above it. Although distinct, bounded balls of plasma can form anywhere at modest scales. As for instance, and as we shortly see, the tiny balls of ball lightning on Earth. For really big ones in space, it is helpful for them to come to rest in spaces free of gravitational pulls. And when such a niche appears, it is pretty certain that it will soon be filled by plasma, which will form a ball as big as the niche allows. And that is why L4 and L5 points are perfect homes for huge plasma clouds, for they are the only 2 points between the Earth and the Moon free of gravitational pull from either the Earth or the Moon. This image is not drawn to scale, obviously, and The relative sizes of the bodies are shown to bear no relation to their true size because obviously you're saying they're both of them together are 9 times bigger than the Earth. So yeah, obviously it's not drawn to the correct size. This image is intended solely to show the geometrical spatial configuration. Seen at this scale, the Earth and the Moon would be extremely tiny, or perhaps even too small to see, as the main text explains. Each of the clouds are 4.5 times the size of Earth. Image drawn from the author by image drawn for, not from, for the author by Eric Wright. This matters because, as I will show, there are good reasons to believe that plasma, which its ordering properties can in certain circumstances be in some sense alive and can evolve intelligence. Because plasma is made up of charged subatomic particles, it is volatile and displays a tendency to form complex, constantly evolving patterns. You know, Dom might get a kick out of this. Perhaps he was talking about he made a video earlier recently about something about proving God through physics or whatever, and it was like some kind of fibers, like making infinite numbers of patterns and shit, like infinite numbers of patterns or some shit. I mean, I think plasma probably has a is relevant to that. But anyway, this is particularly true of discrete bundles of plasma that we will call plasmoids, such as the Kordylewski clouds. What a plasmoid is will be explained fully later. Though this may surprise or even shock many readers who may find this implausible on the face of it, I will also show that nearly all scientists in the field believe that the universe is more than 99% made of plasma. Although this too has not yet filtered down to the general reading public, because you can't be telling the secrets, right? And if the Kordylewski plasma clouds are examples of an inorganic life that has existed for billions of years, they may, as I hope to show, have had a role in forming this planet throughout its long cosmic history. They may even help to create organic life. Clearly, these ideas taken together open up vast new and very fruitful areas for speculation on the origins of the cosmos and the role of intelligence within it. In fact, I will be arguing that life in its basic state is inorganic, and it is not made out of atomic matter. I suggest that it is made out of pre-atomic matter, namely the atomic particles, electrons and protons and ions, plasma. Thus, I am suggesting that we and all living things in the universe, were whether organic or inorganic, arise from this plasma, and that the organic state is secondary to our fundamental nature as plasma beings. I believe that we can now start to articulate a new science of heaven, quote unquote. Book title here. That is what the book is about, and that is what I propose to do. I will also show that, as well as being very new, these ideas are also, in another sense, very old. Ancient religions and philosophers in the classical world, including Aristotle, Aristotle formulated very similar ones. They might not have been able to to apply mathematical measurement to assess the levels of complexity necessary for life and intelligence that modern physicists can now apply. but a shift in perspective caused by the new physics of plasma will cause us to reassess many ways of understanding the world previously dismissed as discredited or even cranky. I will not enter into theological discussions and will confine myself to the new science, with the exception of a brief historical review in Chapter 6 of some very religious texts that have relevance to our subject. I believe that much of what we have previously called spiritual is really plasma, and that it exists all around us and in us. Many spiritual experiences reported throughout human history are really encounters with plasma phenomena or plasma entities. What does this mean for religions? I believe it leaves them all untouched. My primary purpose is to reconcile the spiritual, quote unquote, with the material, quote unquote, and thereby to show that the dispute between them is false. There is, in fact, no contradiction between them when one digests the teachings of the new science. All right, chapter 2. This is a short chapter 1. Chapter 2 is even shorter. Exploring the nature of plasma clouds and their energy. I first got to know Professor Chandra Wickramasinghe in the 1970s, along with his colleague and mentor and former teacher, Sir Fred Hoyle. It is appropriate that this should be the case because Fred Hoyle was famous not only for being one of the world's leading astrophysicists and theoretical astronomers, but for writing the science fiction classic The Black Cloud, which is about an intelligent cloud in space. I will refer to that book again later. The Kordylewski clouds are not clouds in the usual sense of being made of water vapor and being within our atmosphere. There are two of them, as we have seen, roughly centered around two precise points in space between the Earth and the Moon. What kind of clouds could possibly exist at these points? After all, they are in what we used to call outer space, quote unquote, so what could be there to make a cloud? The clouds are composed not only of the subatomic particles already mentioned, but also of dust particles. That may that may not sound very exciting, but uh, that is because you may well not yet know how important, complex, and incredible a dust cloud in space is. Space dust is described thus in a 2008 technical paper. Quote, dust is a generic name for minute solid particles with diameters less than zero point 0.1 to zero point 0.5 millimeters. The use of a range of size rather than a specific number for the cutoff indicates that this upper limit for dust size is somewhat arbitrary and scientifically insignificant. A plausible argument for the range that is that particles greater than these sizes are unlikely to float in the air by themselves. There is also a somewhat arbitrary lower limit of a few nanometers to distinguish dust grains from more fundamental particles such as the electrons, protons. Therefore, this choice of the lower quote unquote limit includes small clusters as dust, end quote. It is useful to read this, but it is not entirely satisfactory for us because it speaks of dust floating in air, and there is no air in space. However, it can act as a kind of approximate guideline for us about sizes of dust particles, whether single or clustered. Hiccups. Astrophysicists also sometimes like to speak of dust in space as grains, quote unquote. And although much dust is spherical, in space, much of it is elongated and hence green shaped. Also, there headset cut off. Sheesh. And although much dust is spherical, in space much of it is elongated and hence green shaped. Although there is a lot of lumpy, clumpy, and irregular dust in space, not all dust contains atoms. But that will have to be explained later when I tell how plasma makes its own dust of itself. Plasma is essentially made up of two subatomic particles, electrons that have a negative charge and protons that have a positive charge, and ions, incomplete atoms, quote unquote, which also have a positive charge. In whole atoms, there is a balance between the negative and positive charges. Physical matter, quote unquote, is really atomic matter because in order to be physical, quote unquote, it has to be made of whole atoms. However, an atom can be turned into an ion by the simple means of stripping it of one of its electrons. It is important to realize that ions are not considered to be physical matter and that they are charged. And to give some idea of the relative sizes, it is usual for a charged dust particle to have 10,000 electrons sticking to its surface. Because protons are larger than electrons, they do not stick to dust particles in quite so high numbers. Contrary to what we might assume, living as we do in a material world, particles only very rarely come together to form whole atoms, and non-atomic plasma is the main constituent of the universe, more than 99% of it. As I say, we will see shortly why scientists think this, but the important point here is that from this perspective, atomic matter is exceptional, and hard rocky planets are very rare indeed. It is because there is more plasma than there is atomic matter, and I view ions, protons, and electrons as primary, and whole atoms as secondary. This way of looking at things will, I hope, become clearer as we go along. We will see later that our sun spews out huge quantities of positively charged protons and ions and fills the whole solar system with them. So our entire solar system, including the Korolevsky clouds, is constantly being inundated with a never-ending flood of ions and protons. Since space is full of furiously racing and whizzing particles, of both negative and positive charge, it is not possible for a dust cloud to exist without each single dust particle within it being massively bombarded with thousands of subatomic particles, which, as we have seen, are much, much smaller than the dust particles, and thus becoming charged itself. It is well known by all scientists working in this field that the surfaces of dust particles or grains, quote unquote, are continuously being charged by a relentless rain of thousands of electrons and positive ions striking them. When those are equal in number and the positive and negative charges balance out, the dust particle is said to have a net zero charge, quote unquote. However, this is a rare event, and even when it occurs, it is likely to be transient and exist only for only a few instances. In our own solar system, the Kordylewski clouds are exposed to this relentless and never-ending hurricane of positive charge coming from the sun in the form of solar wind. The sun also emits some filaments or streams of negatively charged electrons as well, but they are far less important components of the solar wind than the positively charged ions and protons. There are such things as negatively charged ions, and they can exist within plasma. but they are not important for our discussions in this book, and we will not refer to them again. One might well ask, if there are sustained streams of positively charged particles being emitted by the sun, why does the phenomenon not have a name in the way that streams of negatively charged particles, known as electrons, are called electricity? It was Peter Mitchell, 1920 to 1992, a very dear friend of mine, who took steps to fill this gap in our language, naming such flows of positive currents proticity. Peter won the Nobel Prize for Chemistry in 1978. He even built a mechanical motor that operated on proticity. Yeah, well, these electric cars with their electric motors. Well, how about this proton motor, motherfucker? You know, where'd that go to? He called it a protic motor, and he built it to show that proticity instead of electricity, proticity could be a source of energy to drive a motor sitting in front of you in the same way as electricity can do. And then we never hear of it again. I'll tell you right now. So I shall use the word proticity from time to time to describe the flows of positively charged currents, even though the word is still used only rarely by others, because Peter worked on a highly specialized and closed branch of bioenergetics. Not enough people ever knew of his terminological innovation for it to spread to the wider public. Peter is so little known that the general public, that his obituary, which I wrote, is included here as Appendix 2. My efforts to locate Peter's protic motor in recent years have drawn a blank, alas. I just hope it is still preserved somewhere, and though if so, it is possible that no one knows what it is. You know the fucking government has that shit, bro. Like, come on. The government has that shit locked up for the foreseeable future. Because the Kordylewski clouds and others like them are bombarded with without by from bombarded from without by charged particles, the particles inside them and the dust interact with great intensity and complexity, evolving, as we shall see later, highly complex patterns. Such a large charged dust cloud in space is known as a dusty complex plasma, quote unquote. One of the things which distinguishes such an entity is that all the processes inside it cannot be described by physicists using simple linear equations. Everything taking place inside this kind of plasma operates in a manner described by nonlinear equations. When something is linear, it means there is a direct and identifiable connection between cause and effect so that one can predict behavior. But when linearity breaks down, everything becomes unpredictable and immensely complex. It is important to bear nonlinearity in mind because it is a feature of quantum mechanical supercomputers now in development. An analogy with these will play a part in arguments later in the book to show that these clouds may be highly intelligent. Quantum computers break their information down into a different kind of bit, now called qubits, quote unquote. The Q, quote unquote, stands for quantum, quote unquote. Because quantum theory is a bit weird. A qubit can have the values of 0 and 1 at the same time. Oh dear, that's a headache. Very much like, quote, having our cake and eating it, end quote. Some say that qubits can have any value between 0 and 1, which could be, that's basically limitless then, right? Meanwhile, the more restless and rusting and thrusting of the computer developers look upon qubits as being so yesterday, quote unquote. They now say the future lies not with qubits, but with qubits, quote unquote. A qubit can have 10 or more values at once. Sheesh. This is like having 10 cakes and eating them. Yeah, no shit. One might say that the work being done today on quantum computers is an attempt to construct computing devices that can do nonlinear reasoning, quote unquote. Direct causation is linear, but some circumstances allow all sorts of unpredictable outcomes and unexpected influences. Direct causes that might take place in an ideal world get interrupted and blocked, and things come at you from the left and the right, and they change things. This, as we will see later, is the inescapable and found fundamental nonlinearity of dusty complex plasmas. One useful definition of dusty complex plasma in a single sentence is by physicist Osamu Isahara. Quote, complex plasma, also known as dusty plasma, is a plasma with micron-sized, a micron is a millionth of a meter, dust particles in which dust particles interact with a background plasma. End quote. That seems like you're using the word that you're trying to define. You, plasma, you're defining as, interacts with background plasma. So it's almost like you didn't define it very well. Anyway, maybe I'm just rambling. This definition dates from 2008, and things have moved on since then. And the people working in the field now just say dusty complex plasma, quote unquote. Also, it is no longer necessarily seen to be the case that the charged particles, dust particles, and the background plasma, quote unquote, should be viewed as separate things that interact, quote unquote. It is probably more accurate to view the dusty complex plasma as a unified entity, which happens to contain not only those two components or states, but many more besides. I will be elaborating on this last point as we move along in the discussion, and it is also not the case that the dust particles must be micron-sized. They can be much smaller than that, namely nano-sized, 1 billionth of a meter. It is surprising how many scientists, including distinguished professors and experts, still do not understand what is a dusty complex plasma. Science has fragmented so much that they do not even know what the people down the hall in the next lab are doing. That is specialization for you, compartmentalization, right? Complexification of techniques. Excuse me. There are some developments that tend to make research into plasma better known. Very few plasmas are used to deposit circuits onto microchips, so there are large numbers of people working for the huge corporations making these semiconductor chips. One of their greatest concerns is the various types of plasma. Indeed, there are huge profits to be made by getting a new and useful angle on this subject. Many new developments are therefore understandably subject to close corporate secrecy. In addition to these corporate considerations, the military and security people are hard at work on plasma, and they do not shout from the rooftops either. And why would they? The number of advanced plasma scientists who do openly publish new findings and are free to do so is very small. And one of them, and when one of them dies, such as Padma Kant Shukla, 1950 to 2013, all of his colleagues in the field feel as if a whole wing of a mansion has been closed down. Such was the vastness of his knowledge, and such is the sense of loss of both himself and of his wisdom and experience. We will see later that heroic free thinkers and researchers have suffered from the attempts of the Nazis, the Soviet military, and security complex, the CIA, and others to control their work. Chapter 3, A Brief History of Plasma Research. Do I want to keep going here? Yeah, we can probably keep going. Do chapter 3 as well. A Brief History of Plasma Research, Chapter 3. If plasma research is little known even in many academic and scientific circles, it is pretty much unknown to general readers. In fact, many of the greatest and most brilliant scientists of the age have been involved in researching the area, including several Nobel Prize winners. I am proud to have counted some of them as my good friends, to have corresponded with them and discussed their ideas. This book includes a historical view of plasma research. I have written it partly because its implications for our understanding of extraterrestrial intelligence, and indeed our own intelligence, are astonishing. I will start with a brief account of how the terminology of plasma evolved, and this chapter will also introduce some of the eccentric personalities, mind-blowing ideas, and amazing discoveries that feature later in the book. In 1879, Sir William Crookes, 1832 to 1919. Oh, 1919, interesting. He was what, 80 something? Like 87? An English scientist discovered in his laboratory in London something strange, which he called the fourth state of matter, quote unquote. Crookes was a chemist as well as a physicist. He discovered the element thallium, for which he is also famous. In 1895, he identified the first known sample of helium, but it was the discovery by Crookes of what he called radiant matter, quote unquote, which we now call plasma, that changed the whole physics and chemistry, the whole of physics and chemistry. He had been studying cathode rays, which are rays of electrons. He established that they traveled in straight lines, that they could cause fluorescence and generate heat in a Crookes tube, the vacuum tube or valve, which was first invented by him. He had opened the door and let in the subatomic particles. I have Crookes's first published report of it in front of me as I write, since I own an original copy of the Proceedings of the Royal Society of London from 1879 to 1880, which contains it. It is on page 469, and it is entitled "On a Fourth State of Matter," quote unquote. Perhaps it is worth my quoting one of Crookes's astounding concluding remarks in that paper, which I believe has never been reprinted until now. Quote, These considerations lead to another and curious speculation. The general view is that the molecule, intangible, invisible, and hard to be conceived, it is the only true matter, and that which we call matter is nothing more than the effect upon our senses of the movements of molecules, or as John Stuart Mill expresses it, quote, a permanent possibility of sensation, end quote. But in Crookes's view, the space covered by the motion of molecules has no more right to be called matter than the air traversed by a rifle bullet can be called lead. From this point of view, then, matter is but a mode of motion. At the absolute zero of temperature, the intermolecular movement would stop. End quote. This statement in 1879 certainly gives us something to think about at the subatomic level, and it can readily be seen also that Crookes was anticipating the phenomena later to be known as superconductivity and superfluidity. Phenomena we will return to when we come to consider quantum mechanical qualities in plasma that may help give rise to intelligence. The great genius Nikola Tesla 1856 to 1943, who invented alternating current and thus likewise played a huge part in bringing about the existence of the modern world through making it possible for everyone to have electricity, describes frankly in his autobiography that he only decided to study electricity and commence his electrical inventions such as the Tesla coil because of inspiration from Crookes. In his 1919 account of his life, Tesla wrote, quote, 2 or 3 months before I was in London, in company with my late friend Sir William Crookes, when spiritualism was discussed and I was under the full sway of these thoughts, I might not have paid attention to other men, but was susceptible to his arguments as it was his epochal work on radiant matter, my italics, which I had read as a student that made me embrace the electrical career. End quote. Later in life, Crookes became so interested in the possible existence of a spirit world, quote unquote, that he attempted to apply scientific techniques to psychical research, excuse me. He became something of a hero to the general public of Victorian and Edwardian England for his boldness in that, but many scientific colleagues pulled their longest faces and accused him of losing his senses and betraying science. However, as we shall see in chapter 6, when we consider plasma and matter spiritual, Crookes's intuition may have been well ahead of his time and may have been amply justified. Is there a pun in there? Maybe. Amply. Today we call matter in this fourth state plasma, quote unquote. The name given to it by the American scientist Irving Langmuir, 1881 to 1957, who would win the Nobel Prize for Chemistry in 1932. He coined the term because the way a charged gas carries electrons and ions reminded him of the way blood carries red and white uh, corpuscles, no, corpuscles. So the plasma seemed to him to be alive, quote unquote. His historic introduction of plasma, quote unquote, as a new word in physical science, appeared in print for the very first time, together with the word sheaths, quote unquote, for the skins, quote unquote, of plasmas, in an article entitled Oscillations of Ionized Gases, which was published in August of 1928 in a scientific journal, where he wrote these memorable words, quote, "The word plasma, quote unquote, will be used to designate that portion of an arc-type discharge in which the densities of ions and electrons are high but substantially equal. It embraces the whole space not occupied by sheaths, quote unquote." End quote. It was then that the science of plasma physics was truly born. All the work had been done since 1879 on what has been called ionized gases, quote unquote, or radiant matter, quote unquote, become known retrospectively as plasma research. 1941, Lyman Spitzer, 1914 to 1997, suggested that interstellar dust particles might be acquiring charge from their electrons in the form of ionized gas, quote unquote, Spitzer's preferred name for plasma. Ionized gas, quote unquote, was, as we have just seen, later abandoned. We now know that all interstellar dust is probably charged, but in 1941, this was an astonishing new idea. 1954, the Swedish scientist Hannes Alfvén 1908 to 1995 suggested that planets and comets in our solar system might have been formed as the result of, excuse me, of the coagulation of dust particles in the solar nebula that have that had been charged by plasma. He won the Nobel Prize for Physics in 1970. 1955, Winston Harper Bostick, 1916 to 1991, created the first artificial plasmoid blob of plasma in his laboratory. 1995, Peter Leonidovich Kapitsa, 1894 to 1984, suggested that ball lightning was really a spherical plasmoid, a type of plasma, which between 1930 and 1934, he was the first director of the Mond Laboratory at Cambridge. 1958, Eugene Newman Parker proposed the existence of a solar wind, quote unquote. This proposal was first made by Peter A. Sturrock, with whom I carried on a correspondence on other subjects many years ago, and James Hartle. We now know the solar wind to be two different kinds of plasma wind emanating from the sun. One is called the slow solar wind, quote unquote, which travels at speeds between 700 and 800 kilometers, S1. But because the sun is rotating clockwise, the beams do not go straight. They swirl with the rotation and from an Archimedean spiral shape in space, and hence swish across us rather than blasting straight at us, as illustrated in Figure 2. Is it down here? Yeah. Swirling. Inherent in them is a powerful magnetic field. The Ulysses spacecraft launched towards the sun in 1990 detected and thus confirmed the existence of these separate solar wind components. In 1994/1995, the space between the Earth and the sun is completely filled with solar wind plasma. But prior to 1958, the quote establishment scientific opinion end quote said that quote outer space is empty end quote, which was composed solely of vacuum. 1958, the Allen radiation belts, two donut-shaped belts made of plasma surrounding the Earth were discovered, which we now know to be made of plasma. These will be considered in Chapter 4. Also in 1958, the United States exploded a 10 megaton atomic bomb in the high atmosphere. These are the words of the author, not mine. I uh, because of that B word there. I don't know how if YouTube really cares though, but we'll see. At 75 kilometers or 46.6 miles, in order to produce an artificial aurora and study the plasma regions below the above the planet, not below. The follow-up studies were still on a year later, so lasting was the damage to the high atmosphere. Many more such atomic blasts followed. It is now believed that all of these atomic explosions, apparently about 100 of them, and other crazily ill-advised military tinkering, quote unquote, with the high atmosphere by both sides in the Cold War, contributed to the instabilities of worldwide climate that we see today. Swerving, swirling. Figure 2. The central dark spot is the Sun. The dotted line is the orbit of Earth, intentionally simplified here to look like a circle. The solar wind is not blasting straight at us, but is swirling in this way, with the swirls sweeping across us. This drawing is taken from Alexander Peel's excellent book, Plasma Physics, second edition, Springer Verlag, Heidelberg, 2010. He does not give his source for it, and the speed has been indicated wrongly by the unknown artist, nor is the rotation taken into account for the spread of indication of account for the speed indication. But the basic idea is clear, namely the Archimedean spiral form of the solar wind, which fills our solar system. 1959, my friend Thomas Gold, 1920 to 2004, coined the term magnetosphere, quote unquote, to describe a tear-shaped region of magnetized plasma surrounding the planet, which protects it from harmful aspects of the sun's solar winds. Tommy is also Tommy also conducted important research on the universe's continuous creation of matter, an important area of study that is very relevant to complex dusty plasmas, as we will see later. 1960, Theodore G. Northrop and Edward Teller, 1908 to 2003, provided the theoretical explanation for the existence of the Van Allen belts. 1961, in the Soviet Union, David Albertovich Frank Kamenetsky, probably butchering these names, aka Frank Kamenetsky, also mistakenly aka Kamenetsky or Kamenetsky. That's a lot of names, variations of spelling. 1910 to 1970 suggested that in an article for a technical journal that plasma may exist within living organisms. He thus anticipated much of the subject of the latter part of this book. 1962. Chandra Wickramasinghe, while still a PhD student of Sir Fred Hoyle, 1915 to 2001, at Cambridge University, proposed that the dust known to exist in interstellar and intergalactic space, until then thought to be ice grains, was really made of carbon. This entirely revolutionary idea, uh, important to this book, because we have seen complex dusty plasmas contain such dust as was accepted by the astronomical community 5 years later. 1963, David Pines laid the foundations for quantum plasma physics and collective behavior in solid-state plasmas, by his studies of the properties of electron plasma oscillations in high-density, low-temperature quantum plasmas, end quote. In other words, the wobbles that happen in plasmas are at extremely low temperatures. This may sound very obscure and technical, but we will see later that it was fundamental to the advance of plasma physics, including with regard to plasma's capacity for bringing out some of the weirder quantum phenomena into the macro world. At the same time, my friend Peter Mitchell, 1920 to 1922, published his full chemiosmotic theory, quote unquote, explaining that the energy functions of biological systems are based upon subatomic particles. This explanation came to be known as vectorial metabolism, quote unquote, because it describes the directions of space and energy usage within the body. In 1972, Peter introduced the same. Uh, Peter introduced the term proticity. As already mentioned, he was awarded the Nobel Prize for Chemistry in 1978. See, we're on page 22 or 21. Say 21. How long is this chapter? This is really long. A lot longer than the other two combined, probably. Where was I? David Pines laid foundations for quantum plasma physics. I think I already read that. Yeah. 1982, J. Hill and Davamita Asoka Mendes suggested that the spokes, quote unquote, so-called by astronomers because they so-called by astronomers because they resemble the spokes of a wheel found in the rings of Saturn the previous year by Voyage 2, consists of dust that has been charged in a plasma. In 1986, Hiroyuki Ikezi, something like that, predicted that plasma could exist as crystals. He called them column crystals, quote unquote, named after Charles Augustin de Coulomb. Did I say Coulomb? I mean Coulomb crystals. 1736 to 1806, a pioneer of studies of electricity. He said these crystals could be formed by dust particles in a plasma. This is one of the this is one of the key discoveries concerning the subject of this book because crystals play a vital role in storing information in ways necessary for the evolution of intelligence and communication. As we will see later, it will be 7 years before Ikezi's prediction was proved to be correct. 1989, Gary S. Selwyn and his team at IBM published his discovery that plasma actually manufactured dust, and that the dust found inside fusion reactors and other sources uh, inside fusion reactors and other sources would was not dirt or contamination, but had been assumed, but quote was credited by the plasma itself, end quote. In his dramatic experimental discovery, Selwyn was able to show by laser like scattering that starting from single molecules, dust grew naturally from not nanometer sizes up to micrometer sizes within the plasma. This changed the world of the science of plasma research. Until then, plasma just had been a viewed fit, quote unquote, to and how to avoid the contamination by the dust or dirt was the focus of research attention. But once it had been demonstrated by Selwyn, excuse me, Selwyn was a Selwyn was able to show by laser light scattering that starting from single molecules, dust grew naturally from nanometer sizes up to micrometer sizes within the plasma. This changed the whole of the science of plasma research. Until then, plasma dust had been viewed as dirt, quote unquote, and how to avoid the contamination, quote unquote, by the dust or dirt was the focus of research attention. But once it had been demonstrated by Selwyn that plasma made its own dust, everything changed. And it was at this point that it became possible to envisage what we now call dusty complex plasma in order as a unique and very special type of plasma. 1993, Herbertus M. Thomas, I'm not sure if I'm pronouncing that right, and Gregor Eugene Morfill announced at a plasma conference that they had discovered that the plasma crystals predicted in 1986 by Casey, who do really exist. In 1994 they published their research. At about the same time, two other teams were published papers making the same claim. One by Julian Hawk Chu and Lin the first, and the other. Excuse me. Uh, At about the same time, two other teams published papers making the same claim, one by Jun Ha Chu and Len E. or Len I, not Len the first, I'll tell you that, and the other by Yasuki Hayashi and Kei Tachibana. As I will explain later on, the dusty complex plasmas tend to contain plasma crystals, but why? But it was only in 1983 that it became possible for scientists to make this assumption and confidence to with confidence to begin searching for them in earnest and to include the crystals in their models of the complex interior structures of the plasmas. In 1997, Jesper Schau, Philip Scherer, and their team at Stanford University discovered gigantic plasma rivers flowing beneath the photosphere, commonly called the surface, quote unquote, of the sun. A NASA press release from the Goddard Space Flight Center and at Greenbelt, Maryland, released 94 to 184, dated 28th of August 1997, announced the discovery of quote jet streams end quote or rivers quote unquote of hot electrical charge gas called the plasma charged gas called plasma flowing beneath the completely new discovery. We had found a uh, jet-like flow near the poles. This flow is totally inside the sun. Is it is completely unexpected and cannot be seen at the surface. Schau's colleague Philip Scherer was quoted saying, "quote These popular streams are on a small scale compared to the whole sun, but they are still immense compared to atmospheric jet streams on the Earth, ringing the sun, ringing the sun at about 75 degrees latitude. They consist of flattered oval regions about 17,000 miles across, where material moves about 10%, about 80 miles per hour, faster than its surroundings. Although these are the greatest structures, uh, the, these are the smallest structures yet observed inside the sun. Each still each is still large enough to engulf two Earths. Shao and Schur also discovered that these rivers of plasma extend at least 12,000 miles below the sun's surface, quote unquote, this i.e., this photosphere. Even more extraordinary, Shao and another colleague, Alexander G. Kosovichev, Kosovichev, yeah, known as Sasha, quote unquote, also discovered 6 additional plasma belts flowing beneath the surface, quote unquote, each of which is more than 40,000 miles across. If you add the widths of these flowing plasma regions together, they come to 257,000 miles toward width of following uh, miles total width of flowing plasma streams beneath the sun's surface, quote unquote. Just just to put it just to put this number in perspective, it is greater than the average distance of the Earth from the moon, which is 238,855. What was that note? Test. Mike's still working. I thought for a second something was going wrong. Anyways, where was I? Just to put the miles to The orbit is not a perfect circle, hence the average, quote unquote. This discovery showed that dusty complex plasmas can contain fantastically intricate internal structures consisting of gaseous, liquid, and solid crystal plasma components, and that the crystals can liquefy and the liquids can crystallize. Dust and dusty plasmas are ubiquitous in nature, occurring in interplanetary and interstellar clouds, dust rings around planets like Saturn, on the surface of the moon, noctilucent clouds, night shining clouds, in the mesosphere, third layer of the atmosphere, just above the stratosphere, or thunder clouds. Pause. Okay, where was I? Start back here somewhere. End quotes. Oh, that's not an end quote. That's the quote there. Hmm. Well, let's start here. I think, yeah, somehow we got down the page somehow. In 1997, Jesper Schau, Philip Schur, and their team in Stanford University discovered gigantic plasma rivers flowing. But I already read that. Yeah. Kosovichev. Yeah, read that. Yes, we're here. The ways in which charged dust forms self-organized systems, quote unquote, in plasma is key to this book. But because dust can be so varied, we might well ask if we need special kinds of dust in order to have self-organization take place, or will any old dust do? On this point, there has been a surprising recent discovery announced on the 28th of November 2019 in Nature. It was a news story about a paper just published in Physical Review Letters, whereby some scientists at Northwestern University in America had shown that, quote, tiny plastic beads wandering aimlessly through water can spontaneously form organized swarms and clusters, just like swimming bacteria, end quote. The polystyrene spheres, quote, artificially replicate bacterial swarming, end quote. This was accomplished by putting the microspheres in oil and subjecting them to pulses from an electric field. As a result of this, the spheres became electrically charged and began to, quote, to suddenly spin and propel themselves through the liquid, end quote. By altering the pulses, the spheres were made to cluster together into large clumps. After this, by shortening the pulses, the result was, quote, the formation of one continuous roiling swarm of beads, end quote, which resembled the swarming of bacteria. When confronted by this kind of behavior in inanimate particles, simply as a result of the influence of electrical fields, one realizes that what seems to be, quote, informed behavior, end quote, or self-directed behavior, quote unquote, can manifest without life in the conventional sense, uh, even being present, much less in charge. This is a rather sobering realization. If the same behavior exhibited by bacteria can also be seen in inanimate plastic spheres, then what does this really mean? At a fundamental level, we see here with the lifelike behavior of uh, inanimate particles so precisely mimicking living things that even the very definition of life, quote unquote, is threatened. We need to keep we need to keep uppermost in our minds that the question, what is life, quote unquote, is not going to go away. And we will need to bring it to bear when we consider the question of whether or not plasmas can be said to be living, intelligent, and conscious. The phenomenon of the pattern clustering of microparticles is fundamental in dusty complex plasmas. When it happens, the clumps are known either as Coulomb balls, quote unquote, or once again named after the scientist Coulomb, as with the earlier case, or as Yukawa balls. The latter are named after Hideki Yukawa, 1907 to 1981, the Japanese Nobel laureate physicist. Figure 3. A Yukawa ball, which consists of several hundred dust particles uh, clustered together. The ball, uh, which is a strongly coupled quote unquote term for describing electric elements of a system, such as particles which have powerful interaction energies holding them together. Dusty complex plasma structure is approximately 7 millimeter across. The spherical cluster has a nested shell structure and is not just random inside. These balls are self-assembled. Such Yukawa balls can form even at room temperature and do not need to have an exotic environment of very high or very low temperatures. Quote from Torben Ott et al. Molecular dynamics simulation of strongly correlated dusty plasmas, 2010, quote unquote. Is that a quote? Uh, no, that's just the subtitle for this figure 3. Turning back to the question of the dust comes where the dust comes from, in addition to the discovery that plasma manufactures its own dust. In 2017, Hamish Gordon and his collaborators revealed that the atmosphere also manufactures its own new particles, quote unquote, spontaneously from gas within the air itself. The new particles are nano-sized and they form in clouds in the Earth's atmosphere from condensable vapors. The authors of this report in the Journal of Geophysical Research state, quote, new particle formation has been estimated to produce around half of cloud-forming particles in the present-day atmosphere, end quote. They define new particle formation as, quote, the process by which gas molecules collide and stick together to form atmospheric aerosol particles floating in the air. Aerosols act as seeds for cloud droplets, end quote. A paper later in the same year by Robert Wagner and his collaborators, which included Gordon, reported further, quote, the formation of secondary particles in the atmosphere accounts for more than half of global cloud condensation nuclei, end quote. They went on to say that their experiments at CERN revealed that the formation of these particles was aided by ions in a positively charged plasma. Quote, our results indicate that ions enhance the nucleation process, the formation of nuclei around which particles can grow, when the charge is necessary to stabilize newly formed clusters, end quote. In the autumn of 2018, a further paper appeared on this subject by Dominic Stolzenberg, Paul M. Winkler, and their collaborators. They said, quote, nucleation and growth of aerosol particles from atmospheric vapors constitutes a major source of global cloud nuclei, end quote. And further work on this subject was published in Nature in October of 2019 when Christina J. Williamson and her collaborators, I get tongue-tied too easily, reported crucial new findings about the subject. This team of researchers has discovered that new particle formation in the atmosphere, quote, persists at all longitudes as a global scale band in the tropical upper troposphere, covering about 40% of Earth's surface, end quote. They say that global climate models do not take account of this, and the existing climate models, quote, underestimate both the magnitude of tropical tropospheric NPF, new particle formation, and the subsequent growth of new particles to CCN, cloud condensation nuclei, sizes, end quote. Accordingly, all public climate change discussions at the moment are deeply flawed because they rely upon inaccurate models. I don't think he gets too political with this. That's like kind of what he talks about. Only mentions that this particular thing briefly. Anyway, this team says, quote, new particles form in the atmosphere when condensing gases form stable clusters with diameters of more than 15 nanometers or so, end quote. They, they then say that these particles are too small for detection by satellites, which are unable to detect particles smaller than 100 nanometers. That is why this important phenomenon has been missed, because it is so difficult to detect by our existing technology. As a result of these new findings, NASA has recently set up a program to try to obtain more detailed information about these new particles in the atmosphere. So that we can know how they affect our climate models and, of course, our climate itself. The formation of these tiny particles out of nothing, quote unquote, is in our atmosphere is very similar to the formation of tiny particles out of nothing, quote unquote, in plasma, as both are a result of clustering processes within the two separate media of plasma and air. and both processes are quite recent discoveries. The plasma processes have been known for several years now, though not widely so. And as we have just seen, the atmospheric processes are not are an even newer revelation. The similarities of quote appearing to get something out of nothing end quote in both plasma and in air suggests that a universal process is being manifested in the two different cases. And considering that, it is perhaps not surprising there is also another way of getting, quote, something out of nothing, end quote, which has been known since the 1990s, and it operates at an even more fundamental level. I am referring to the creation of a type of subatomic particle known as a baryon. Experiments have verified that the creation of baryon particles can occur when whirling vortices are created in a fluid medium such as helium-3, 3 He, a form of helium with the quality of superfluidity, quote unquote. This phenomenon is an important part of some of the weird quantum effects associated with plasmas, as we shall see shortly, and it arises where liquids can flow without resistance. Flow without resistance. Oh, yeah, superfluidity, yeah, no resistance. A key article revealing a particularly important finding about this was published in Nature in 1997, and I kept that issue of the magazine folded over to that article to remind me ever since its publication in the spring of that year. It was the group led by TDC Bevan who published this key article about what they called baryogenesis, quote unquote, creation. Bevan went on to publish much more about this type of thing over the succeeding years, but but this particular article was the first time that the creation of baryons by this method has been demonstrated in a laboratory. Quote, here we describe experiments on 3He that demonstrate the creation of excitation momentum, which we call momentogenesis, by quantized vortices flows around an axis at a quantum level of smallness in the superfluid. Our results provide quantitative support for this type of baryogenesis, creation of baryons, end quote. I cannot take space to explain this fully or do justice to the details, especially as it involves discussing quarks' chirality, spectral flow, quote unquote, and all kinds of things that sort, which are not necessary in this book, but may be found by consulting the many papers of Bevan and his teams directly. The main thing to come out of all this is the demonstration that those nuclear particles known as baryons have been created in the laboratory and that they are also being created in a similar manner throughout space in superfluids, such as those to be found as we shall discuss later in dusty complex plasmas. So here, we see clearly and repeatedly that it does not take something to create something, as it can just as readily be created by nothing. Mm, very strange. That flies in the face of Parmenides, doesn't it? Because it's Parmenides that was the one who stated, "Out of nothing, nothing comes." Where this seems to be implying that something does come out of nothing. But there might be a mistranslation, or it might be lost in translation here in in the conceptions, in the defining of terms. But I wouldn't know how to parse that out really at this stage. Anyways, so what is existence if it can suddenly appear like that? He seems to be taking it like that. The plasma physicist who has done the most to call attention to the creation of matter within dusty complex plasma clouds is without question the Russian scientist Vadim Nikolaevich Saidovich. Saidovich, I think that's how you pronounce it. Born the 17th of March 1929 in St. Petersburg, then called Leningrad, died 2015. For many years, he published articles and books reporting on advanced findings from dusty complex plasma research, showing that something which looks life very looks very much looks very like life can be produced in charged dust clouds. In one article in 2007, he stated clearly, quote, "It is concluded that complex self-organized plasma structures exhibit all the necessary properties to qualify them as candidates for inorganic living matter that may exist in space, provided certain conditions allow them to evolve naturally." End quote. Saidovich and three colleagues, including brother Sadruddin Benkada, apologies, were very specific about the self-organization within dusty plasmas of lifelike phenomena, especially in an article that they published in 2000 and which I shall quote in a moment. But one technical word, dissipative, needs to be explained first. Right, I remember this because it seems opposite to what the word looks like it means in this context. It does not refer to the common use of the word dissipation, quote unquote, to describe overindulgence in sensual displeasures in pleasures. Dissipative, quote unquote, in this sense, was first introduced into science in 1972 by the Belgian mathematical theorist Jan Camille Willems. Camille, something like that. 1939 to 2013, and became widespread because of its adoption and development by Ilya Romanovich Prigozhin. Dun dun dun, Prigozhin has entered the chat. 1917 to 2003, the Nobel laureate for chemistry in 1977. Prigozhin entirely revolutionized the science of thermodynamics, which is essentially the study of the actions of heat and all that follows from them. Until Prigozhin, it was widely believed that the universe was steadily running down, that things slow down and fall apart, as the second law of thermodynamics says they will. What Prigozhin discovered and proved was that energy brought into a chemical system, instead of always contributing to a process known as the increase of entropy, the progressive increase of disorder, end quote, could be dissipated away in the entropy dissipated away into other directions and purposes that were productive and could form open interactive structures such as life forms. No, known technically as dissipative structures, quote unquote, these structures being like isolated islands of positivity in a sea of increasing entropy and hopelessness, could instead become increasingly complex and self organizing systems. This is huge. At least I think it is. It's huge when eh, the blanket assumption was that the law of entropy was running the universe down, as in it would be in the with the big crunch, right? The the eventual heat death of the universe. But if what it apparently says here that Prigozhin discovered and proved was that energy brought into a chemical system instead of always contributing to entropy could dissipate away the entropy into other directions and purposes that were productive and could form open interactive structures such as life forms known technically as dissipative structures, isolate ions of positivity, um, could instead become increasingly complex and self-organizing systems, the exact opposite of entropy, I would think. You know, you have entropy, which is tends toward disorder, but increasing complex and self-organizing systems would be increasing order, not decreasing it. Prigozhin built upon these discoveries his concepts of self-organization, which are now at the heart of what we are finding in dusty complex plasmas. So what Prigozhin did was no less than explain the central role of life in the universe. That's a big statement to be able to say of the whole universe. Explain the central role of life in the whole universe. Although this was by no means heard by anyone, it was the philosophical death knell for the mechanical universe. This is huge. I think it is. And so we return to Seidovich and his colleagues and to plasma. Here are further comments made by Seidovich and three colleagues in 2000. Quote, self-organization processes in dusty plasma are expected to be very important since the latter is an open system with a high rate of dissipation. A high rate of dissipation provides rapid development of self-organization processes and formation of long-lived dissipative structures. Dusty plasmas is an open system where the rate of dissipation is high and there is a tendency to self-organization. New types of nonlinear interactions are possible in dusty plasmas. End quote. Nonlinear, that just that just messes with my head, man. As it was talked about, he talked about it earlier. Not direct cause and effect, direct lines of cause and effect, with things interfering and all kinds of stuff. The importance of dusty plasmas being open systems, quote unquote, is that they can absorb energy from outside, which then fires the growth of a complexity. The Kordylewski clouds undoubtedly feed, quote unquote, on energy from the sun this way. In the next year, in 2001, Seidovich published a paper, Evolution of Voids in Dusty Plasmas, on the important subject of voids or empty spaces inside dusty complex plasmas. Quote, it is shown that formation of dust voids is a general phenomenon in dusty plasmas, end quote. Voids are of immense importance in general, though rarely recognized. He went on to explain that whereas both dust structures and dust voids are formed in some plasmas, they cannot happen in a purely homogeneous dusty plasma. There can be no internal architecture if the dust structures are not separated from one another by voids. A structure must be separated from the rest of the mass by a space, for otherwise there is no longer a distinct structure. It is surprising how rarely people think of this. The human body is full of voids, and if it were not, you could know you could not differentiate the kidney from the liver or the stomach from the lungs. Technically, these voids within our bodies are known as body cavities, and if the Kordylewski clouds are to have the complex internal structure that we know dusty complex plasmas to have, then they too must contain voids or cavities. In 2004, Seidovich and his friend Gregor Eugene Morfill, I think that's a typo there, should be, because he said his name earlier, Eugene Morfill, another of the world's most distinguished plasma scientists, published a paper making clear that it is the nonlinear character of the dusty complex plasmas which makes the self-organization of the internal structures possible. Quote, dusty plasmas are unusual states of matter where the interactions between the dust grains can be collective and are not a sum of all paired particle interactions. This state of matter is appropriate to form nonlinear dissipative collective self-organized structures. End quote. They pointed out that such findings were compatible, quote, with recent results of structure observation in the experiments of on the International Space Station, end quote. There were numerous plasma experiments carried out on the space station because scientists were eager to see how plasmas behave in a gravity-free environment. Many results have come from this work. In 2014, a major paper was published by Seidovich and Alexei Ivlev, Andreas Burkert, and his old friend and colleague Morfill. It was long and important. It was a long and important review article entitled "Compact Dusty Clouds in a Cosmic Environment." In this paper, Seidovich and his colleagues pointed out that in order to be stable, a dust cloud must self-organize and fill itself with clumps, quote unquote, and internal structure. If a dust cloud remains smooth, it will be destroyed. Like smooth brain or some shit. Never mind. They also said that such stable clouds can be as small as 1,000th the size of the Earth and still cohere. So we have their assurance, therefore, that the Kordylewski clouds must contain internal structure and be self-organized in order to have survived. And they further add that this is all possible by remaining optically thin, and quote unquote. In other words, being invisible. Hmm. The authors also say that within dusty plasmas, dust can confine itself into stable spherical clusters. Quote, spherical dusty clouds can be formed, suggesting that this process of dust self-organization might be a generic phenomenon occurring in different astrophysical media. We argue that compact dusty clouds can represent condensation seeds. In other words, they can provide the necessary conditions for a population of small-scale cold gaseous clumps in the diffuse interstellar medium. They could play an important role in regulating its small-scale structure and its thermodynamic evolution. Self-organization of dusty complex plasmas has been observed in numerous experiments. Different types of structures formed in dusty plasmas under microgravity conditions in experiments performed on the International Space Station, as well as on the ground, include compact clusters, voids surrounded by dust shells, vortices, etc. We predict that this process can occur in a broad range of plasma parameters, which indicates that such self-organization might be a generic phenomenon operating in different astrophysical media. End quote. The giant spherical cosmic clouds discussed by Seidovich and his colleagues having between 10 and 100 times the distance of the Earth to the Sun as their diameters are much bigger than our Kordylewski clouds. And the giant ones he is discussing are also seen as forming in interstellar space between the stars in a far thinner medium, whereas the smaller Kordylewski clouds are in our own system, in our own solar system, with a much denser medium and with the constant feeding of energy into them by the solar wind. Sergei Vladimirov, another of the famous plasma scientists, also has written, quote, "The dust plasma system is an open system. Strong interactions of dust particles and their openness of the system led to self-organization and structurization, quote unquote, of initially homogeneous uh, dust clouds into a complex aggregate of dissipative dust structures. These structures become quasi-stationary within short timescales. In other words, they very rapidly become almost stationary." End quote. In another paper, Seidovich, Morfill, and four other colleagues stressed how plasma crystals inside the dusty complex plasmas could spontaneously form helical structures resembling DNA. Quote, "Complex plasmas may naturally self-organize themselves into stable interacting helical structures that exhibit features normally attributed to organic living matter. The self-organization is based on physical mechanisms of plasma interactions. As a result, each helical string composed of solid microparticles, dust, is topologically and dynamically controlled by plasma fluxes leading to particle charging. These interacting complex structures exhibit thermodynamic and evolutionary features thought to be peculiar only to living matter. We examined the salient features of this new complex state of soft matter, quote unquote, in light of the autonomy, evolution, progenity, and autopoiesis. Autopoiesis refers to a system capable of reproducing and maintaining itself, principles used to define life. It is concluded that complex organized plasma structures exhibit all the necessary properties to qualify them as candidates for inorganic living matter that may exist in space provided certain conditions allow them to evolve naturally. End quote. This outspoken declaration could almost constitute a number two, I believe, a headset conking out. Where was I? This outspoken declaration could almost constitute a manifesto for the Kordylewski clouds, though it was published 12 years before their existence was confirmed. Of course, helical structures in humans have functions of storing and communicating information. So the crucial question raised here is, could helical structures in plasma have the same function? And could these be the seeds of an alternative evolving form of life? The authors go on to say, quote, big quote, memory and pre-production are necessary for a self-organizing dissipative structure to form a living material, quote unquote. The well-known problem in explaining the origin of life is that the complexity of living creatures is so high that the time necessary to form the simplest organic living structure seems, quote unquote, too large compared to the age of the Earth. Can faster evolution rates be achieved for non-organic structures, in particular in space consisting mostly of plasmas and dust grains, i.e., of natural components spread almost everywhere in the universe? If yes, then the question to address is, are the above necessary requirements of self-organization into a kind of living creature, quote unquote, present in plasmas containing macro particles such as dust grains? Here we discuss new aspects of the physics of dust self-organization that can proceed very fast and present an explanation of the grain condensation into highly organized structures first observed as plasma crystal. Our analysis shows that if helical dust structures are formed in space, they can have bifurcations, instances of splitting, as memory marks and duplicate each other, and they would reveal a faster evolution rate by competing for food, quote unquote, surrounding plasma fluxes. These structures can have all necessary features to form inorganic life, quote unquote. This should be taken into account for formulation of a new SETI-like program based not only on astrophysical observation, but also on planned new laboratory experiments, including those on the ISS International Space Station. In the case of the success of such a program, one should be faced with the possibility of resolving the low rate of evolution of organic life by investigating the possibility that inorganic life invents, quote unquote, the organic life, end quote. The passage specifically says that dust structures can replicate, in other words, like helical DNA molecules instead inside dust clouds. Inorganic living entities are then formed that, quote, compete for food, end quote, in the form of sources of incoming plasma, which they eat. As we have seen in the case of the Kordylewski clouds, most of their food, quote unquote, consists of the solar wind coming from the sun. All of this happens at a faster rate of evolution than is the case with organic life, and its development would outpace organic evolution by billions of years, hence clearly gaining dominance. And it also occurs to me that if these Kordylewski clouds, are eating the solar wind, which is energy, then that would mean when the sun reportedly increased in size by 30%, Earth didn't get burnt up. Perhaps the Kordylewski clouds were a lot smaller back then, but since the sun got larger by 30%, the increase in energy was eaten up by the Kordylewski clouds. I mean, it's a possibility. I don't know if that's actually what happened or whatnot, but I mean, it is kind of interesting to think about. Where am I? From this point of view, we as organic humans are rather primitive latecomers to a fantastically ancient tradition of inorganic life forms. And as they say, a new SETI-like program, end quote, should be started. SETI, SETI, as many readers know, stands for Search for Extraterrestrial Intelligence. After all, who needs little green men when you've got gigantic intelligent clouds on your doorstep, which are billions of times more intelligent than any little green men could ever be, billions of years older than any possible organic life form, and the entities who must, in effect, be the true masters of the universe? It's a I don't know if you would say that the Kordylewski clouds could be the true masters of the universe. You could say maybe the true masters of the solar system, perhaps. Um, but it's still an interesting thought. Throughout this book, we will be looking at research from around the world, particularly America, which complements and reinforces the world of Vadim Nikolaevich Saidovich and his colleagues, with dust, quote unquote, made by plasma itself replacing atoms, quote unquote, as the building blocks, living bodies can be formed. We might consider the charged dust to be dust atoms, quote unquote, or perhaps more accurately, dust molecules, quote unquote. And from them, charged plasma entities can emerge by the process called self-organization. That means that no outside source needs to create them, as they can create themselves. By this means, plasma people can exist who are imperceptible to the optical nerves of the physical people, quote unquote, who are made not of plasma but of flesh and blood. Because we are incapable of directly perceiving the plasma people, we do not know they are there. And furthermore, they may be of such diffuse matter that they can pass through our dense physical matter and emerge intact. You mean kind of like ghosts? Sorta? Scientists scientists know that ball lightning does this. As we will discuss in chapter 4, spiritual beings such as angels are also said to have this capability, which we will come to in chapter 6. If what these scientists are showing, as I for one and I for one think they are, is that the internal structures of the two clouds could be so complex that at such a vast scale that they surpass any possible human knowledge at this time. The storage capacity for information would easily include the ability to retain full knowledge of everything that has ever happened in our local cosmic environment for 4 billion years. Everyone who has ever lived will be recorded. Every creature that has ever roamed the surface of the earth will be recorded. Every plant which has ever grown will be as well. The presiding consciousnesses, or what psychologists call the executive ego states, quote unquote, of the two clouds, will have personalities so alien from our own that we cannot conceive of them. Since the clouds evidently exist as a pair, they may be married, quote unquote, uh, or at least in a civil partnership. The questions are only just beginning. And I think I'll end it there. Well, I'll start chapter 4 next time.